This video is for potential construction project engineers, people considering a career path in the construction industry, or current project engineers who want to understand the job better and how to take their career to the next level. The purpose of this lecture is to give you an overview of construction project engineering, and it's part of a series of lectures I'm going to be doing that give you a complete overview of the skill set of project engineers. In this lecture, I'm going to cover the job role and responsibilities of a project engineer, the what, how, and why of project engineering, the difference between a design engineer and a construction engineer, and the different accreditations you need to get to become a successful project engineer. Before we get started, we need some context. So I'm going to start off by going through the construction industry and how project engineers make a mark on construction projects. We need to understand what project engineers do and why general contractors employ them. And by understanding how general contractors make money, we can understand the job role and responsibilities of a project engineer. So how do infrastructure projects get built? Well, the first step is we need to start with a need. Projects get built to solve a problem. Then someone needs to come up with a solution to this problem. So if the problem was we don't have enough electricity, then a power plant would be the solution to that. If the problem was we've got too much traffic, then a road or a new tunnel could be a solution to that. So a project developer will come up with a solution to the need. They'll then refine this solution. They'll do a needs analysis, a feasibility study, and work out if it's actually possible to build the project. The next step is they need to find a general contractor to build it for them. They'll come up with a concept design, specifications, an idea of what they want to build. So they might decide they want to build a road from position A to position B. They decide they need 3 highways, the road needs to have 6 lanes, that there's 2 traffic intersections where they need traffic lights, and they need street lighting. This all goes into concept design. And then from this, they need to find a contractor to build it for them. So they'll take this set of concept drawings and issue it to the market to get quotes. Different contractors then quote to deliver the project for them. Contractor A might say, it's going to cost us $10 million and will take a year to build it. Contractor B might say they can build it in 9 months for $7 million, and contractor C might say they can build it in 2 years for $20 million. The project developer will then need to choose a contractor to build it for them. So in this case, Contractor B probably sounded like the best options because they're the cheapest and the fastest. From then, the project developer and the contractor will negotiate and sign a contract, and then construction can begin. From there, the general contractor will take the drawings and specifications, and if it's a design and construct project, complete the detailed design, a set of drawings, then they'll procure their own contractors, or they're referred to as subcontractors, and then start the construction phase. They'll bring on earth moving equipment, start clearing land, and start delivering the project. They'll then finish the project, make sure everything's done correctly, make sure it's fit for use, and then hand it back over to the project developer. The project developer then pays the contractor for the work they've completed in accordance with the fee the contractor originally quoted. Then the project's ready to start being used. Traffic users can start using the road. So let's look at a case study of this. I'm going to use the example of a solar farm, primarily because I work in renewable energy and I work on solar farms. So let's start with the need. The need of a solar farm is obvious: to produce green electricity. Once the need's been sorted, the project development phase can begin. So the project developer will need to decide how big the solar farm they want, where they want the solar farm to go, how they're going to access the solar farm, whether they want a tracking system or whether they want fixed panels. This all goes into the concept design and the feasibility studies. They'll then need to finance the project. When they're ready to go, they'll need to procure an EPC, or an engineering, procurement and construction company. This is a company that's going to deliver the project for them. In the same way with our road project, they'll probably get quotes from multiple contractors. So contractor B will quote, contractor A will quote, and contractor C will quote. The project developer then needs to choose the company that they think is best fit to do this for them. So again, say they choose contractor B, negotiate and sign the contract, and then construction works can begin. The EPC will procure all the panels, the trackers, the inverters, they'll start building the access roads, and they'll deliver the project. Once they've finished building, they've done all their checks that it's correct, and they prove it operates, they then hand it over to the project developer, and they can start producing power. So that's how you go from a need or an initial problem that the infrastructure needs to solve to a functioning piece of infrastructure that's producing power. From this process, how do contractors make money? Well, really occurs in two stages. The contractor needs to quote a figure to the project developer which they can do the project. Stage two is they then need to deliver the project for less than this fixed fee. The amount of money between what they quote to deliver the project and what they get paid by the client for delivering it is their profit. If we look at this, the profit equation, we've got the revenue, which is the payment from the client, and the cost, which is the cost to deliver the project. The profit that's left over for the contractor is the revenue minus the cost. Pretty simple, isn't it? Simple, but difficult. So then we can break this down into the two core business activities of a contractor. Number one, they need to secure profitable projects. Number two is they need to deliver these projects for less than what they quoted. Our focus is going to be on part two of this equation. Why is that? Because early in your career as a construction project engineer, you'll be working on projects. It's generally more senior people who work on tenders and in the pre-contract space. Although as a junior engineer, you might end up helping out on a tender, which is great experience. Most of your time early on in your career is going to be on delivering projects. So that's why in this series of project engineering lectures, I'm going to talk about the skills you need to deliver projects profitably, because they'll be the foundation of your career early on. So, how do you deliver a project for less than what you think it's going to cost? That is the core of what construction project managers have to do. General contractors employ us because we can help them deliver these projects for less than they cost. We can't do that. The company's not going to stay in business for very long, and our jobs aren't going to be very secure. So to answer this question, we're going to think about this a different way. We're going to reverse engineer a successful project. And so ask the question, what would a project have to be to make money? So what do we need to do to complete the project scope for less than our cost? Well, let's think about this a couple of different ways. The first is we should only do the work that we quoted to do. Nothing more and nothing less. If we said we're going to build a bridge with 2 lanes with street lighting, that's what we're going to do. And that's all we're going to do. We're not going to do anything extra unless we get paid for it. 2, if we're responsible for the design, we need to develop the cheapest, most cost-effective detailed design. So this would apply for any design and construction projects. This isn't as applicable if the project developer uses a constructor-only model and they retain the design responsibility. Next, we need to find fantastic subcontractors at a great price. Any project is impossible to do using our own internal resources. Even a simple road project will have multiple different trades. There's earthworks, concrete works, line marking, you need electricians for the lighting. There's a range of different trades. And doing this all in-house with a company's own internal resources isn't going to be possible. Number 4 is we need to build it efficiently without waste. We need to make sure the project runs smoothly. We can't have trades being delayed. We can't be wasting materials. We really need to do things as efficiently and effectively as possible. Number 5 is we need to build it quickly. This is important because the longer the project takes, the more it's going to cost us. While there's the direct cost to complete the works, there's also going to be a lot of time-driven costs. At night we'll need security guards. We'll need construction management and project management staff. Every day the project takes us to do is going to cost money. 7 is we need to ensure our suppliers and subcontractors only do what we pay them for. We're going to be paying our subcontractors a lot of money to do work, and we need to make sure they're doing it correctly and they're doing what we paid them for. Number 8 is we need to build it correctly. We can't have any defects in rework. We're always going to have some defects in reworks. It's impossible to not make a single mistake. But you think about any project. It involves thousands of different activities. If we're doing all these activities twice because we're making mistakes, we're going to very, very quickly blow our budget. And the last one, but the most important one, and not just for project cost, but we need to make sure nobody gets hurt. Safety is an ethical responsibility. And as construction project managers, it is our job to make sure there are no incidents and nobody gets hurt. So who makes sure all of this stuff happens? Well, project engineers. Project engineers work as part of a team and a general contractor to make sure all this stuff gets done and projects get delivered successfully. General contractors, or as we call them in Australia, head contractors, employ project engineers to make sure the project scope gets done cost effectively, safely, and on time. We know a project engineer is employed to do all this stuff. We can then define the job role of a project engineer. A project engineer applies construction project management skills to ensure the job gets done safely, correctly, and on budget. Project engineers apply skills like project scheduling, procurement, contract management, cost estimating and cost control, and quality management to make sure the project outcomes are achieved. So now, we've established the context. We understand how projects get built, what general contractors do, and why they employ project engineers. And we understand the job role of a project engineer. Next, we're going to move on to looking at each of these project engineering skills in a bit more detail. These are the skills that are going to be the backbone of your career. Project scheduling. This is the skill we use to deliver the project fast. Or maybe not fast, but at least on time. So a project engineer is going to use project scheduling to develop, implement, and monitor and control the schedule. Project engineers need to understand the overall schedule. They need to develop a short-range program for their scope of works and then track, monitor, and control progress to make sure the works actually get done on time. Procurement. Procurement is the process of finding good yet cost-effective subcontractors and suppliers to deliver the project. Project engineers need to be able to understand and implement the procurement process to achieve project outcomes. They need to be able to write a scope of works and prepare a tender package, get quotes from the market, and then with these quotes, choose the best subcontractor or supplier to work on our behalf. Cost estimating. This is the skill we use to understand costs and make informed project decisions about costs. As a project engineer, you're going to need to be able to accurately estimate the costs of construction works and complete quantity takeoffs. You'll then use this information to make better project decisions. Contract management. This is the set of skills, tools, and processes we use to manage all of the contractual relationships on the project. There's really two groups of contractual relationships. As the general contractor, we have a contract with our client. This is referred to as the head contract. Then, we've got all of the contracts with our supply chain or subcontractors. These are referred to as subcontracts. As a construction project engineer, you'll be involved in both the head contract and subcontracts. The head contract, you'll need to be able to support the project manager and commercial team in managing, although you probably won't be directly involved in the head contract unless it's a small project. And then you'll also be responsible for managing subcontracts. As a project engineer, you'll be directly managing and the point of contact for subcontracts. So like a concreting trade, an electrical trade, a hydraulic trade, you'll be managing these sorts of packages of works. So you need to know everything about contracts and how to manage a subcontract. You also need to be able to review payment claims and manage variations. Quality management. This is the tools and processes we use to make sure what we're building complies with the design and specifications. In other words, these are the tools and processes we use to make sure that what we're building is correct. As a project engineer, you'll need to be able to implement a quality management system, prepare and write inspection and test plans and inspection and test check sheets, and then obviously implement them during construction, You'll need to be able to prepare non-conformances if construction works fail. And then you also need to be able to manage a punch list. Design management. This is the set of skills we use to interpret the engineering drawings and manage changes to the design during the construction phase. Now, I'll talk about this a little bit more later, but design engineers and construction engineers always get confused. People think, quite often on site, people think I'm the one who's prepared the drawings. But project engineers don't prepare the drawings. We're simply there to manage, interpret, and implement the design. So what we need to be able to do is read, interpret, and communicate engineering drawings. We need to be able to manage design changes during the construction phase through the RFI process. We need to be able to manage vendor design development. So this is where we get subcontractors who complete detailed design on our behalf. We need to be able to manage them, and we need to be able to document design changes and prepare the as-built drawings. So this is another revision of the drawings after the construction phase is complete. Cost control. This is where we track, monitor, and control costs to deliver the works efficiently. As a project engineer, we need to be able to understand and manage construction budgets. Remember, we're here to deliver a set of works for less than what we thought it was going to cost us, so for less than our budget. So our budget is everything. We also need to be able to track, monitor, and control costs. And then when we're overspending, we need to be able to identify and implement treatments to correct the overspending. So we've discussed all the project engineering skills. We've discussed project scheduling, procurement, contract management, and cost estimating. So what do we get when we combine all of these skills together? Well, we get a fantastic project engineer. And you need to be able to master these skills, understand the tools, processes, and techniques used to implement them on construction projects to excel at your job. A super common misconception about project engineers is that we're the same as design engineers. That's not true. Project engineers complete a very, very different job to what a design engineer completes. Design engineers create drawings. They're the ones in the office reviewing specifications and standards, reviewing the original project requirements, and coming up with a detailed set of engineering drawings that show exactly what we're going to need to build. The design engineer job role is much more technical. Design engineers specialize in either electrical, mechanical, civil, structural, how to size a concrete foundation to hold a light pole. That's the responsibility of the design engineer. Their job is preparing the drawings. Project engineers, on the other hand, are like mini project managers. Their job is to coordinate and deliver construction works. They're involved in interpreting the design and understanding the design requirements, but their job isn't to prepare the drawings. Their job is to implement them. Project engineers don't have design responsibility. That's probably the biggest misconception. Tons of times on site, I've had tradesmen or workers ask me, are these the drawings I prepared? And everyone thinks that's what engineers do. All engineers are design engineers. But that's the big misconception. Project engineering is very, very different to design engineering. Although, as a project engineer, one of your main jobs will be liaising extensively with the design engineers and architects. It's your job to read and interpret the drawings and communicate them to subcontractors, suppliers, and workers, and effectively make sure that what we're building matches the drawings. That is probably the biggest role of a project engineer. But that's done in the context of a project. So you're not just blindly implementing the drawings. Your job is to implement them in such a way that the company we work for can still make money. So it's not the technical role. It's also a commercial role, the project management role. You have to understand schedules. It's much, much more than just a technical set of skills. What qualifications does a project engineer need to have? Well, you need an engineering degree. So whether you study electrical, civil, mechanical, typically, while it's less specialized than design engineering, we often see job positions as electrical project engineer as opposed to a civil project engineer or a mechanical project engineer. So you do use the technical skills to some degree. That's mainly in terms of reading and interpreting the design drawings. The big one you need in my opinion, is construction project management skills. And this is something that people don't often learn at uni. You spend all your time learning about the technical skills, about electrical engineering, about civil engineering, less about project management, and much, much more about the technical side of engineering. And then when you start working, it's completely flipped. Your job is much more about project management and much, much less about the technical side. And then you can also go on and get further accreditations. For example, I've got my PMP, my Project Management Professional, and I'm also a chartered engineer in Australia. So I've only got my engineering chartership. So there are additional accreditations you can get after your degree. But often in jobs, they're not mandatory. At least in Australia, that's the case. What makes a good project engineer? Now, this is a diagram I've prepared that I've spent tons of time thinking about what goes into a project engineer who's really, really good at their job. And the structure of the triangle is probably different to what you think. The bottom of the triangle, or the most important thing, I think, is soft skills. These are your communication skills, your teamwork skills, your emotional intelligence, your time management skills. And this is something I've sort of realized later on in my career, that you can still be really, really good at your job if you're super organized and super good at working with people. If people like working with you, you can reach out to people to ask questions, and you're super, super organized, you've probably covered 70 to 80% of what makes a good project engineer. The next set of skills I think you need is you need project management skills. You need to understand procurement, contracts, estimating, cost control. These sort of skills will basically define how you operate to make sure that you're working toward the project outcomes. While they're much less important than what's required for a design engineer, you do need technical skills. If you're an electrical project engineer, you need to understand electrical engineering. You'll be ordering electrical cables, you'll be checking that electrical works are correct, you'll need to organize test meters, so you need to know what type of test meters you need. So you do actually need an understanding of technical skills. However, it's much, much less important than what a design engineer needs. If you come off a base of really good people skills and really good project management skills, I think you can get by with the technical side of things by simply just being really organized and being really good at working with the right people. However, you do still need good technical skills. And then at the top of the pyramid, which I think is the skill that will take you to the next level in your engineering career, is business skills. You need to understand what a construction company does and how they make money. These business skills will then take you to the next level of your career, where they take you into project management, and even above that, program management and organization management. So the business skills, I think, is a skill that as a junior project engineer, you don't really need, but in terms of taking your career to the next level, that's the skill you need to master. So what's next? As I said, this is a series of lectures I'm preparing about construction project engineers. And I'm going to go through each of the skills you need to get to excel at your job. I'm going to go through project scheduling, cost estimating and management, quality management, and all these sorts of skills that can turn you into an amazing project engineer. So if you enjoyed this and found this valuable, then make sure you stay tuned for what's next.